in tanneries, the management, the engineers, the workers, the tannery owners, everybody should be aware about the management of the chemicals, spills, accidents, and other things. And finally, as I mentioned, the awareness of inputs to outputs and the processes. What I am giving in the drum, how much it is absorbing by the layers or heights in skins, how much is giving the load to the wastewater, you have to calculate. For this you have to ensure about the exhaustion of the bath. I will discuss it later. Now, how can you substitute the chemicals? If I go for the first operation, the biocides in soaking. What are the biocides commonly we are using in the leather processing in the tanneries? These are mainly phenolic base. These are mainly isothiazole base. These kind of biocides are very harmful for the industry. But if you can replace it with the green alternatives like sodium or potassium dimethyl thiocarbamate, it will reduce the pollution load. It will reduce the
Saya ingin nanya,
wastewater
Bu,
treatment
Bu
cost.
Kartina, Kak
It
Kartina
will reduce
di mana
the
nih sekarang?
cost of the
Kak
chemicals.
Kartina.
It will
Oh,
reduce all of the bad things. Might be it can reduce, it can increase some cost, but it will reduce most of the things. The cost increase in production is mitigated, will be mitigated by the wastewater treatment cost. And the second one, halogenated organic compounds, where we are using in soaking the wetting agents, the degreasing agents, the fat flickering agents, in the dyeing agents, and also some of the other post-tanning compounds. We have to remove the halogenated organic compounds. Although many studies has been done, and nowadays so many companies, the chemical companies, they have taken initiatives to reduce the use of halogenated organic compounds. Some already have replaced the halogenated organic compounds in fat flickering agents, in degreasing agents. You know, APOs, alkyl polyphenol ethyl ethoxylates. These compounds are also used in degreasing compounds, in finishing, in another compound, in the fat liquoring. Already it has been banned. And so many chemicals company already produced the best available substances, green alternatives. I will be discussing this in the next slides. And the organic solvents, you know, the solvents generally used in finishing, but nowadays the aqueous based finishing system, solvent free solid finishing system, then polyurethane based finishing, that is the, if you say, it is mainly depends on the aqueous based finishing system. So most of the finishing technology nowadays, they are adopting the aqueous based finishing system. Only the exception is if you want to make waterproof leather, you have to go for some solvent use. You have to use some solvent during the finishing of the waterproof leather. Other than, you can use aqueous system, and low organic solvent based finishing system you can introduce. Suppose, for example, if you go for sheepskin degreasing, you need to use ethoxylates. But nowadays, some of the technology is given importance for making alternative chemicals to use in degreasing. Although it has not been eradicated, but still they are trying to fully replace. Partially it has been replaced. And the surfactants, APs, alkyl phenol ethoxylates. Why we don't use the alkyl phenol ethoxylates and APEOs? Because it is breaking in the solution as alkyl phenols. These are the problem. Why it is problem? Because it is making the disrupting the fertility of the women's or men's fertility problems. Then it increase the vulnerability of the different organs of the human body for different diseases. So we have to replace by alcohol ethoxylates, if possible, where possible. These are the bad substitutes. And the complexing agents, if you think for the complexing agents, we are using EDTA. So what we can do, we can replace the EDTS with EDDS. EDDS means ethylene diamine NN disuccinic acid. We can replace by this. And also the most important is this one, MGDA. That means the methylglycine diacetic acid. Methylglycine diacetic acid. This is the green alternative nowadays, which can replace the EDTA, because where we are metal complex formation and EDTA we are using the we are using it in the deliming process sometimes. So what it can, the MGDA can attract the calciums and other substances by replacing EDTS, because MGDA is far better than the EDTA. And the ammonium deliming agents, in deliming, if you use the ammonia, because you are forced to use this, because the ammonium sulfate is very less expensive. This is very, what can I say, very less cost, very user friendly also. You can use ammonium salt. It is less costly and user friendly. But the problem, ammonia gas and also the ammonium chloride. What we can do, we can replace this. For best available techniques, you can use the weak organic acids. The weak organic acids such as succinic acid, glucamic acid, glutamate, and other acids also. You can use, I will describe this later. For the pickling, after deliming, in betting, it's not a problem, because we are using the, already we are using it by enzymes. So it is not going to create some problems. But for the pickling and tanning, this is a huge problem. In pickling, for chrome tanning, we are using 8-10% salt. This is huge. It increases the cost of the wastewater treatment. And as well as we are reducing the pH. So the pH is 2.8 to 3 in pickling. That also makes the problem of, because the discharge limit pH, it is 8, it is 7 to 9. So if you use only pH 2 to 3, it will going to be create a problem. What we can do, we can adopt, as it is not possible fully to replace the chrome tanned chromium salts until now. We are practicing it in conventionally. What we can do, we can reuse the chrome salts containing wastewater or water. We can reuse the pickle liquor, so that the final liquor of the tanning could be less. It reduces the volume. As a result, it will reduce the cost of the wastewater treatment. And the other thing is, we are using so many chemicals in tanning, sometimes formaldehyde, sometimes acrylic base in retanning also. What we can do in tanning and retanning, we can replace this. We can go for the syntans, we can go for the vegetables, we can go for the organic tanning agent, we can go for the environment friendly one. And the next one, if you go for the next slide, it is about the dye stuffs. Already I mentioned that the dye stuffs, which are from metal based, pre-metallized metals, and some contains salts. If you go for the tannery, they are using the dye stuffs. Most of the dye stuff contains 20 to 25 or nearly 15 to 25% of salts. If you go for the liquid dye stuffs, it will reduce the amount of the salt. So it will reduce the environment pollution. And also high exhaustion of dyes. It is important. If you can uptake the dyes in the leather 90%, 95%, or more than 90%, it will be a great success for the best available techniques. How can you make this? You can adjust the pH, you can adjust the dye formulation, and then you can make this possible. And also substitution of ammonia by auxiliaries such as dye penetrator. You can use an auxiliaries so that dye can penetrate easily and can fix there. And as I mentioned earlier, you have to remove the halogenated base dye stuffs in replaced by sulfone reactive dyes. If you can use one sulfone reactive dyes, the sulfonic group can also react. It can it can give us benefit in two ways. One, environmental terms. Second, the sulfone group, which can facilitate the reaction with the leather. The fat ligaring agents, as I mentioned you, adsorbable AOX, free of AOX, adsorbable organic halogenated compounds or bound halogens. Earlier it was used, but nowadays it is not being used in the leathers. Exception in waterproof leathers. Some of the waterproof leather wants this because it needs some solvents to fix, and that's why somebody can use this. But as much as low amount you can use, it will reduce the COD value and also the treatment cost. And obviously for finishing, if you go for finishing, then earlier, if you know the leather has a characteristic smell. We are telling this, but this is not true. Leather should not have any smell. It should have the smell is coming from the leather is due to by the chemicals what we are using. Mainly, if it is finished, then you are getting the scent, you are getting the smell odor in the showroom from the VOCs, volatile organic compounds. So, in finishing agents, already solvent, the European Union is given a pressure, is giving a pressure to reduce the solvent use, and they will ban the solvent use in leather finishing. So we need to be prepared about this issue in future. Those who have tanneries, those who are fully engaged with the chemical, especially the chemical producer, they have to search for the alternatives. How can they minimize the use of solvent containing chemicals? You have the chemical company should be aware of the solvent free chemicals. And then water repelling agents, as I already mentioned, AOX free chemical you have to go for, other than the waterproof leather. And some of the leather contains, for example, flame retardant leather, phosphate based flame retardants they are using. These are the environment friendly products, phosphate based flame retardants. And as I mentioned earlier, the biocide, THPS or the THPS can be used as the phosphonium salts. You can use it. And now I will go for the process integrated BAT measures. What are the process integrated measures you need to do? You need to maintain. First, you have to control the consumption of chemicals. You do not need to use more chemicals. So you have to increase the power of the chemicals so that it can come in contact with the leathers and get fixed with the leather nearly 100%. It is not possible by 100%, but you have to try to towards 100%, towards 100%. And then you have to substitute the hazardous chemicals by less hazardous one. What are the less hazardous ones? You have to select and use. Then water and waste management. You have to use such kind of chemicals that reduce the water content and also low float. And as if you use less water, it will tend to produce less waste. And then emission, if you don't use the volatile organic carbons, then you are going to release less air polluting substances. And the energy savings, if you use some system control, for example, automated system. You are giving one command to the monitor that you will give only 100% water, then it will give only 100% water. But if you use it manually, then your worker might give 150 water, 150% water. So you have to be careful about this. So what are the process control during curing? As my fellow just the previous lecturer, he mentioned about some of the bio-based techniques for the preservation, but it is not uh, fully practiced in the tannery. So what we are practicing? We are practicing by salt. We are practicing by chilling method. What we can do, we need to use as far as possible the fresh hides directly from the slaughterhouse to the tannery, if possible. Then we don't do not need to use any kind of sauce. But for long-term transport, if you transport from one country to another or one district to another district of the country, you have to preserve the skins. And until now, the best feasible technique is salt preservation, as mentioned by my previous lecturer. He already mentioned it. But what we can do, we can use some techniques which can reduce the salt content during curing. And also during soaking, we are using some chemicals, especially the biocides. As I mentioned earlier, we can use the green alternatives, THPS, so that we can reduce the pollution levels. And another one important problem in our tannery of beam house operation, unhearing and liming. Until now, we are using sodium sulfide. So what the sodium sulfide producing? Hydrogen sulfide gas and a huge load. As we are maintaining the hair burning technology, it is giving a huge load to the tannery wastewater. So that the tannery wastewater, when we are treating this tannery wastewater, it increases the treatment cost. If we can use an alternative method, hair safe technology, enzyme technology, although nowadays most of the tanneries is maintaining the enzymatic technology, they are practicing in some of the country. I found that they are practicing the enzymatic technology, although they have some limitations, but they are trying to cope up with the best available techniques by enzymatic technology so that they can compete with the sustainability factors. And if you use enzymatic technology, you can reduce the sulfide consumption. You can recycle the spent liquors because enzyme is not a problem. But the conventional unhearing agent, that is sodium sulfide, it's a problem. It is creating problem for the environment. So you need to replace this. And then splitting, although it's a good technology, you can make lime splitting so that the split part can go directly. But most commonly, as most of the tanneries are producing from a starting material from wet blue, and some of the tanneries is practicing to produce the shuapa leather, so it needs to be firm, thick enough. That's why this is not so much feasible for splitting, but I just mentioned it. It is not so much feasible. And the deliming and batting, as I mentioned earlier, that process need to be compact. How can we make this environment friendly? By using weak organic acids, by using enzymes, trying most of the chemical company are trying to adopt this, and also the tanneries. So we have to avoid in deliming ammonium sulfate, ammonium chloride, and ammonia-based systems. And then degreasing. Most of the cases, sheep skin must be degreased. In degreasing, we are using the ethoxylates compounds, alkyl phenol ethoxylates, this kind of compounds we are using. We need to reduce the use of these compounds for degreasing. We need to learn for alternative or other solvents. As much as possible, we need to reduce the amount of the organic solvent use. Pickling, I just want to say here, please avoid pickling. How can we avoid pickling? We can avoid pickling by organic substitutes. Suppose organic tanning agents, vegetable tanning agents by partial pickling or by reducing the pH with acid bait. We can directly uh, go for the tanning process by vegetable tanning agent. Or for organic tanning, we do not need to make any pickling. But for chrome tanning, we are forced to do the pickling. For this case, what we can do, we can use some partial recycling liquor. The liquor from previous process, we can use in the new process. Batch-wise, we can separate the pickle liquor. That's by this way we can reduce the 50 to 60% volume. We can reduce the float. And by this way, if you can reduce the 50 to 60% float, you are reducing 50 to 60% of salt use in the pickling operation. As you know, salt is problem. So if it is not possible to avoid pickling, then go for less pickling, go for recycling, go for partial pickling, go uh, for the use of same liquor for different baths. And for tanning, in tanning, we are using basic chromium sulfate in the chrome tanning process. So what we can do, if we use the tanning, if we use the chrome, then we have to recycle this chrome. And it is possible because it has already been established in the tanneries. Most of the tanneries, the chrome recycling or chrome recovery unit. This chrome can be used again and might be in another way. This chrome might be used for another use, especially for circular economy support. And the most important way is to, if it is not feasible to use the chrome again, then you have to search for the high exertion tanning method. How can you increase the absorption capacity of chrome? How you can uptake the chrome more than 90% by the leather? You have to think for this. Already some of the study, they are using 40% basic chrome sulfate, 46% basic chrome sulfate. They are using this to facilitate chrome tanning reaction and more fixation. So high exertion could be a well alternative if you don't have any option other than chromium. And then for vegetable tanning agent, if you use the vegetable tanning agent, you can go for counter current pit system. One vegetable tanning agent, 1, 2, 3, 4 pit. You can use the first from the fourth one, then second, third, then second, then first fresh vegetable tanning agent. You can use this by reducing the pollution load. You can reduce pollution load by this way. And for retanning, what are the chemicals mainly we are using in retanning? Most commonly the acrylic resins, fat liquors. There's the problem. Other chemicals is not so much problem, but these are the main problem. So what we can do in post-tanning operations, we can make some technology by which the process can be controlled, the chemicals can be absorbed more efficient, in a more efficient way, and reduce the salt content of spent liquors. This salt content is not due to direct use of the salt, common salt. It is due to the salt content of the neutralizing syntan. Then vegetable tanning agents, then other retanning agents, most of the chemicals, not all, most of the chemical contains some salt content. So if we can produce these chemicals with low salt content, then it will reduce the salt content of spent liquors, as well as it will reduce the treatment cost of the liquors. And then if you go for the dyeing, the dye stuffs, generally some of the dyes might contain the leads, the nickels. So what we can do, we can remove them. We can use some of the dye stuffs which are natural. We can use this, and some of the most important is the exhaustion of the dyes. If you can uptake more dyes, then it will facilitate you for the clear solution of the wastewater. Then drying, the mechanical dewatering prior to drying where possible. If you can use the mechanical dewatering system as far as possible, then it will not going to produce so much air pollution. And the applying surface coats, this is important for finishing. If you go for roller coating, it is not going to spray, so it is coating. There is no wastage of the chemicals. Directly some amount is coming and fixing on the leather surface. It could be a good option. Curtain coating, the same thing. And the high volume low pressure spray guns, you can use the spray guns by which it can spray in a high volume but low pressure, so that it can make a good continuous film formation into the finishing. And then there is no loss, there is no spray loss. And use airless spray. If you spray by air, it is going to be spread out more. It is making sprinkles and it is making air pollution. So you can control this. If it is not possible by control this way, then you have to set one exhauster by which it can take out all of the solvents. And at the end of the exhauster, you have to set one filter, might be bio-based or another filter which can take all of the VOCs and other hazardous chemicals. You have to put the filter. This could be a best available techniques if we don't have the option to control the chemicals, don't have the option to control the organic solvents. And now in the water management and treatment, how can we use the water? You have to use the best system, not the running water washes. You have to improve the meshing of water flow to the requirement of the process. How can you schedule it? How can you, by a system, you can make it, as I mentioned earlier. By one click, you will make the water management. Low float, short float methods. If you are using 100% of water in a estate, if you can use it 60% float, then you are saving 40%. Use modern equipment for short floats. Modern equipment, you have to use some modern equipment. Suppose, for example, some of the drums. If you can use these drums, you can use less amount of water, short floats. To reuse wastewater, whatever you are producing, you can use it, you can make a circular arrangement. Then if all of that option is not possible, then recycle the liquor if possible. So where it is possible, suppose for liming, you are producing sulfide containing effluent. What you can do, you can separate the lime liquor and then you can remove the sulfide first by increase the pH or other sedimentation or other system, and then you can mix this water to the other waste liquors. It could be an option. And then chrome containing, although it has been practiced in many tanneries that the chrome containing substance, chrome containing liquor, that means the tanning liquor is separated by from any other liquor. There is another pipe by which the only chrome liquor goes to the effluent treatment plant, and they are making a recovery of the chrome, and then they are mixing this chrome liquor to the general wastewater. And then if you use the mechanical treatment for effluent treatment plant, you have to use the mechanical, you have to use the chemical, you have to use the biological treatment also, because one is dependent to other. If you use only the mechanical treatment by which you are taking the garbages and the particle size, which the particle size is more, then you can take this by mechanical treatment. But if you don't make the biological treatment, it is not going to treat the wastewater by the discharge limit standard. And also the sedimentation, if you don't make the sedimentation of the sludge, then you cannot handle this wastewater, you cannot make it discharge to the water body. So you have to sediment, and already it is established in the effluent treatment plant. And process integrated, okay. And the waste management and treatment, generally in tannery there are two types of main waste. One is wastewater, another is solid waste. So what you can do, the best possible way is to prevent when the waste is born. If you can prevent, it is the best possible way, then it is not going to be born. But if you don't have the option to prevent the waste, then you have to go for reduction. And if you don't have the scope, if you cannot control by reduction, then it will produce and you will make the reuse of these substances. If you cannot reduce, then you have to recycle this. That is the 4R technology. Recycle, or you have to recover this to use for another industry. Either it could be intervalorization or it could be intravalorization. It depends. And the final one, what we are doing for the solid waste right now, most of the country are doing the landfilling. Most of the country are doing landfilling. This is not a sustainable way. This is the worst scenario. This is the worst way to manage the solid waste. And the second way, some of the countries are producing energy by incineration. It is also not a better option. But incineration is better than landfilling. Although it is polluting the environment. So incineration or thermal treatment, pyrolysis could be an example. Or pyrolysis, most of the industries throughout the developed countries, they are going for pyrolysis because it produces energy, it produces electricity, it reduces the waste, and also it is producing some ash which can be used for cement construction, which can be used for raw material for where the ash is needed. So I'm going to give some example here. In leather production, split can be used. Nowadays, the recycling of leather and splits are being upgraded to the value-added leather. So this is not a problem. Leather fiber and board production from the splits, not splits actually. We are using the shavings, trimmings, and other scraps for the leather goods. A small leather goods by the trimmings, suppose the finished leather, you are trimming, and after that the trimmings, a small substances, a small leathers can be make some sandals, can be make some parts, small parts for design purpose, different color, fashionable item. And then the filling materials or wool, hair and wool is very much, what should I say? This can be used in many sectors for cotton making, wool making, many sectors. Gelatin, the important thing from raw. Some of the countries throughout the world are making gelatin from the raw skins. So why not from the trimmings, green lime fleshings? It can be used, it can be easily. Sausage casing, yes, untanned splits you can use for sausage casing. Fat recovery, although it has been used already. Collagen hydrolysate or protein hydrolysate, it can be used for fertilizer, agriculture use. Then for composting, you can use the hair and lime fleshing. It is, although it is in under the research, it has not been practically applied until now. I didn't found for composting, but grease, fats, oils you can extract from the fleshings and other trimming waste and other waste. You can extract this. It is easily practicable, and you can make it. Anaerobic digestion, these are not so much feasible, but where there is no scope, you need to do. You can just make the digestion fleshing green line, and then you can extract the uh, valuable product from them. Thermal treatment, as I mentioned,
Dek, dek, dek.
organic solvents,
Kamu mau kemana? Mau ke kanan atau ke
use
kiri?
organic solvent with no mixer, only one solvent, so that you can recycle it, or you can retake this
Kamu mau
from
ke
the
kanan atau ke
solution.
kiri?
And
Oh, kira
if
mau ke
there is no option, you can
workshop. Soalnya
reuse or
saya mau ke
recycle the
workshop, dek.
packaging, pellets, plastic cardboards used in
Mau
the
cari
industry.
apa nama? Saya mau
And the
cari
other
buku.
part is the air abatement. How can you prevent the air
Ya, dek.
pollution? You can bet, if you just adopt
Makasih,
the best
dek.
available techniques, then you can prevent the generation of odors. You have an exhaustor, good ventilation system. You will suck all of the gases produced in the production in the drum. It will sucked, and it will be processed and controlled by the filter, bio-based filter or any filter at the end of the exhaustor. So you can control, if you can take the best available techniques here. Proper handling, you need to manage the storage of the high skills and the wastes also. You should not dump it here and there. And also, if you just dump the fleshings into the environment, it will produce hydrogen sulfide, ammonia, volatile organic carbons. So you have to, if you adopt the best available techniques, you can prevent the release of hydrogen sulfide, ammonia, VOCs. And the must for the LWG certification is to record the energy consumption for electricity, heat, steam and heating, compressed air, how much the energy you are using in your tannery. This is also important. What you can do, you can use the solar energy alternative to a tannery. Suppose you have a big shed, you can put a solar system. It is a best available techniques to adopt, and it can be easily adopted. And then the digital system for monitoring energy uses. If you can digitalize AI based also, nowadays AI is familiar. So if you can digitalize your all of the system, then the chemical dosing, energy dosing, and all of the things you can easily calculate, and there should not be error. And these are the, for some examples, as I mentioned earlier, what we can do in the total processing, as you know, rawhide, beam house, tanning, post tanning, finishing, and finished leather. These are the main parts. So what you can do, you can use low salt preservation, enzyme assisted soaking, water recycling, short flow technology. If you use salt, then you must need to desalt. This is one of the important technique before starting soaking. If you dissolve, you can use this salt again, and then you can reduce the load. And then in wet liming, unairing, hair safe technology you can adopt. Low sulfide liming you can adopt. Enzymatic unairing you can adopt. Control liming you can do. The less amount of chemical dose you need to put, you can control this. And the hair safe technology, hair recovered. So the pollution load by the hairs, here if you adopt the hair safe technology, it will not going to give an extra load to the wastewater. Advantage, 50 to 70% lower sulfite, you can easily understand. And then reduce COD. This is very important, as you know. And then in deliming organic acids, formic, lactic, sulfonic, my time is very less, so I need to finish fast. Organic acid, sulfamic acid, glycolic acid, you can use this, but disadvantage is expensive. So if you want to make some environment friendly procedure, you have to pay attention and you have to expense more. But the important thing is whatever you are expending in procedure in the leather processing, you can reduce the cost of the wastewater treatment. And then in pickling, I suggest, as I suggest earlier, it should be pickle free tanning. If you can go for pickle free tanning, it will be good. Replace mineral substances, chromium, aluminum, zirconium, titanium. You can use the vegetable tanning agent. Avoid aldehyde tanning agents. You can use the organic tanning agents. Easily, it can make more suitable for BAT to adopt the BATs. And the solvent-free leather finishing, you need to use the solvent-free finishing for worker safety, environmental impact, for regulatory pressures by REACH, zero discharge to hazardous chemicals, environmental protection agencies, and from the LWGs. And the future trends. This is my last slide. So what you can do for future? You can go for the bio-based chemistry, bio-based materials, as mentioned by the other speakers, and the enzymatic processing, carbon neutral tanneries, and the AI assisted manufacturing. Why I am provoking AI assisted manufacturing? Because in future, everyone will try to make the AI assisted manufacturing to control all of the systems in a good housekeeping and well mannered. And the circular leather economy, what you can do, whatever the OS, you need to use it circularly for other. Suppose this is a waste from industry, tannery industry, you can use this waste as a raw material for other industry and for leather industry also. By this way, you can make leather circular economy. So already I have taken 1 hour more, I think. So thank you for your patience and and if you have any question, please. Thank you very much.
Okay. Thank you for very much for Dr. Almizan for your interesting presentations. It's been very insightful. I think this is my first time hearing about PETS material. So for the participant, do you have any question? Maybe for the online participant or offline? Okay, well, maybe I would like to ask a question. So, based on your explanations, PETS
Pak,
is...
permisi, bisa saya menumpang? Saya mau ke
Assalamualaikum.
Bapak ingin kemana? Ke workshop atau ke
Please,
Waalaikumsalam.
rektorat ya? Lewat
Mahmud
di
Hussain.
ini ya, lewat belok kiri ya langsung.
I led Institute
Saya ingin menuju
Institute
ke
of Leather Engineering
apa
Technology
nama ke
postgraduate
workshop,
diploma student.
Pak. Bisa saya
Sir,
numpang?
I
Atau
asked
kalau tidak bisa ya tidak usah, Pak.
COD elaboration.
Ya, Pak.
COD elaboration.
Baik, Pak.
This stands for the chemical oxygen demands. That means how much oxygen is needed to make a substance, degraded for the chemical. If you, for example, if you use some chemicals, it contains some carbons. When the carbon need to be dissolved for the water being, then you have to put some oxygen there. And what is going to be the mechanism when we are discharging the chemicals to the environment or water body? It takes the oxygen from the water. That's why water loses their oxygen and going to be oxygenless. That's why the fishes and other animals living in water, they are not getting the oxygen from the water. That's why they are dying. So COD mainly stands for the chemical oxygen demand. Thank you.
Thank you, sir.
You are welcome.
Okay, thank you for Mr. Mamun. Do we have one more question?
Udah pernah gua muntah masuk jalan.
For the online participant, maybe you got one more questions
Terus ya udah
for
nanti.
the offline. No, I don't think so. So maybe we could close our session. But before that, we will be giving the certification for Dr. Amizan. But because you cannot come here, we're gonna give the certification by sharing through the screen, and we're gonna take a documentation